So 7-3, everybody should be here. This is the last lesson before you guys take your quiz next week, Tuesday. Okay, so your quiz is going to be 7-1, 7-2, and 7-3. I will double check and let you guys know on Monday if you're going to have one proof on your quiz. Right now I'm going to say yes, you're going to have one proof, but it may change depending on which questions are on there, how many questions are on there, okay? No more than 10 questions. So, if you're not here, please get here. We're going to start. This is the first theorem we're covering. Parallelogram, opposite sides, converse. We covered opposite sides last class, but now we're trying to prove a quadrilateral to be a parallelogram. So looking at it, it sounds very similar. If both sides, that's super important, it has to be both pairs. Okay, both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So basically, this is like definition of a parallelogram. No, definition of a parallelogram has to do with parallel sides. This has to do with congruent sides. So this is opposite sides. We can see that they're opposite sides. Okay, here's one side. They're opposites. They're congruent. And here are the other sides that are congruent. So giving you a statement on what it's going to look like if it's written. The definition of parallelogram opposite sides. If AB is congruent to CD and BC is congruent to DA, then ABCD is a parallelogram. So looking at this one, opposite sides, that's kind of key. And we're proving it to be a parallelogram, so it has the word converse in it. So opposite sides, converse. Parallelogram, opposite sides, converse. Parallelogram, opposite angles, converse. Last one we did was opposite sides. We had our opposite sides, now we're dealing with our opposite angles. Again, if both pairs, has to be both. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So look here, I have AC. Let me get a highlighter. If AC is congruent, and if BD is congruent, then I can say that this is a parallelogram. So looking at it, writing it, if angle A is congruent to angle C, and has to be both, angle B is congruent to angle D, then ABCD is a parallelogram. So both of them have to be congruent. Both pairs. Opposite sides, parallel and congruent theorem. Keyword here is it has to be congruent and parallel. But keep in mind, this is only one pair of opposite sides. Okay, this is only one pair of opposite sides. So if we're looking at it, I'm going to highlight it. Here's one pair of opposite sides. Okay, only one pair. It's not saying two pairs, it's only saying one pair. So writing this one using a statement. If BC is parallel to AD, and I'll capitalize that, and BC is congruent to AD, then ABCD is a parallelogram. I'm going to give you an example of what it cannot be. So if I were to give you a parallelogram on a test or a quiz, and I were to draw an arrow up here and my congruency marks on the side. Is my pair of opposite sides congruent and parallel? No. One side is congruent, one side is parallel. That cannot work. Okay? Cannot work. That's a no. It cannot work. The same side has to be parallel and congruent for both pairs. Does everybody understand that? Okay. This is the last one, parallelogram, diagonals converse. Okay, we covered our diagonals last class. This is very, very similar. It's basically the same thing, except we're proving it to be a parallelogram. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here it is, again writing my statement, just showing you if BD and AC bisect. What does bisect mean? Anybody? What is it? What does bisect mean? What did you say? Down the middle. Down the middle. Okay, cuts it down the middle. Yeah. So if it's cutting it in the middle, if it's bisecting, you have to remember that word because you will see that word. If it's bisecting it, then each other, if it's bisecting through each other, then A, B, C, D is a parallelogram. That's one way to write it. Or BE, I'm putting E right here in the middle, is congruent to DE, and AE is congruent to EC. Then ABCD is a parallelogram. So the first one didn't give me that E in the middle. It's just saying that they bisect each other. But because I'm putting the E there, I can kind of separate my lines. Okay, I could separate them in two different things. So I can say this side and this side, which is this, or this total, and this side and this side. Those are my diagonals. They bisect each other, okay, which make them congruent, and they are giving me those congruency marks. So definitely understand what the congruency marks mean. If it's 1 and 1 mark, they're congruent. If it's 2 marks together, they're congruent. So definitely try and match them up. This is everything summed up. These are all 5 ways to prove that a quadrilateral is a parallelogram. So again, last lesson, we learned what makes a parallelogram, but this lesson we're trying to prove that a shape is considered a parallelogram. So these are the 5 ways to prove it, and you will see these. Okay, so this is everything that we just covered, all in words. Okay, one slide. This is everything summed up using words and images. Now we're going to do some examples to see what these mean put together. So just looking at it, there is a lot. This is just the same thing with images. So definitely, please make sure you guys know this, what they look like. So when you identify it or when you're marking it on a diagram, you're able to put the correct marks. All right, we're going to go ahead and do this. We want to state either the definition or the theorem with the given information and the image that they're providing us. We're trying to prove that this image right here is a parallelogram. They're not telling us it's a parallelogram, so we need to try to prove it's a parallelogram with what they're giving us. So we're going to state the theorem and the definition. I'm going to do both. You only have to do one, but if you want to do both so you can have it there, you can totally do that. So looking at the first one, try and follow along. If you know the answer, raise your hand and I'll see if you get it right, which you guys have it on your notes. Looking at the first one, it says BE is congruent to ED and CE is congruent to EA. I'm going to draw it because it's not drawn. So I have BE, which is right here, is congruent to ED, and CE is congruent to EA. Does anybody have an idea of what theorem this is? What is it?
Bisect.
Okay, it has the word bisect in it, but it's not called bisect. Good. Parallelogram's diagonal converse. I'm dealing with my diagonals, and I'm proving it to be a parallelogram, so I have to have the word converse in there. So writing what the theorem is, it's parallelogram, diagonal, converse. Now I'm going to write the definition so you have it. Okay? Bisect. That is something that has to be in the definition. If diagonals of a quadrilateral, I'm going to shorten it, bisect each other, then it is a parallelogram. Okay, and highlight so you know which one's the theorem. Parallelogram, diagonal, converse. All right, looking at the next one. Angle, BAD. So I'm going to draw that angle right here. Angle BAD is congruent to angle DCB, and angle ADC is congruent to angle CBA. Looking at that, what theorem did we use? Are we dealing with angles or sides? So I know I have to have some sort of parallelogram, angles, converse, but I'm missing a word. Okay. No. Good. Parallelogram, opposite angles, converse. So parallelogram, opposite, they're opposite angles, converse. Okay, and writing the definition just so you have it. If both pairs, both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. All right. Next. BC is parallel to AD. So here's BC. Oops, parallel. Parallel represented with an arrow. If BC is parallel to AD and AB is parallel to CD, what theorem am I using? This is more of a definition. This is definition of a parallelogram. That's just the definition of a parallelogram. Opposite sides are parallel. Okay, two pairs of opposite sides are parallel. That's what that one is. Go, Basu. All right, now we have BC is congruent to AD. Okay, so drawing my congruency marks. And AB is congruent to CD or DC. What is that? Parallelogram, opposite sides, converse. Okay, so just highlighting my theorems that I'm using so it's not getting mixed up with the definitions. And then what does it mean? If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And then the last one. BC is parallel to 80, and 80 is congruent to BC. Okay, so now I'm only dealing with one side. So what's this one? It's opposite and parallel. This is just called opposite sides because I'm only dealing with the sides. Opposite sides parallel and congruent theorem. That's the last one. And this is one pair of opposite sides. Yeah. Of a quadrilateral are congruent and parallel, then it is a quadrilateral. Then it is a parallelogram. And you could just draw the symbol. Okay, so this is everything in one image. This is all the theorems in one. And yes, you have to remember all the theorems because they're not going to be given to you. You will get multiple choice, but you have to know when you're using converse and when you're not using converse. Or we're trying to find x and y, and then we're trying to prove it to be a parallelogram. So what is it? So the entire thing would be parallelograms. Opposite, we're dealing with sides. And we're trying to prove it to be a parallelogram, so I'm going to stick the word converse. Okay, so what is that telling me? That's telling me PQ is congruent to SR. And PS is congruent to QR. How would I solve for X and how would I solve for Y? Making my congruency marks. This, or I'll highlight them. Nope, we'll make our congruency marks because you know how to make them. This side is congruent to this side, and these sides are congruent to this side. So solving it, what am I solving first? Yeah.
X minus 9 is equal to 2x plus 1.
Good, that's what I'm going to solve first. I'm going to highlight which side I'm solving first. I'm going to solve this side first because I need to solve for X in order to solve for Y. So I have x plus 9 equals 2x minus 1. And then I have to solve the other side to plug in my x for y. So once I get that answer, plug it in for x plus 7. And then that's going to give me my y. So if I solved it, what does x equal? What does x equal? Good. If I solved it, x is going to equal 10. Subtract x. 9 equals x minus 1. Add 1 to both sides. 10 equals x. Plugging it in over here. 10 plus 7 equals y, which is 17 equals y. Okay, so that one's pretty easy. All right, looking at the next one. Looking at this one, I'm dealing with angles. What theorem am I using? Keep going. Good, good. You guys are getting the hang of it. Parallelogram, opposite, angles, converse. So, stating what's congruent, opposite angles are congruent. Here's my opposite angles. Here are my opposite angles. Set them equal and solve. You have x, you have y. X, I have 3x minus 32 equals 2x. And then y, I have y plus 87 equals 4y. You guys go ahead and solve it. What do we get for x? X equals 32. And what about y? 29. If you solved it correctly, that's what you should have got. Do I need to show the work?
Yeah. For y.
For y?
Yeah.
All right, I'll do y. Subtract your y. These are going to cancel out. You're going to get 87 minus or equals 3y. Oh, that's it? That's all you wanted me to show? That's it. Y is 29. Okay. Last slide. Proof. This one only has 3, so bear with me. 3 and then that's it. Draw your 2-column proof. Statements, reasons. The first one is what? Always. Angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CDB, and that's given. All right, please, I know you guys know this. Don't say you don't, because you do. Looking at my diagram, the given's already drawn for me. What can you tell me about my angles? They're congruent, yes, but what do we know about them? Thank you, they're alternate interior. So look, if this was alternate interior, okay, what kind of lines do I have to have in order to call something alternate interior? Not congruent lines. Good, they have to be parallel. So by knowing their alternate interior angles, I can write that I have parallel lines. So showing you my parallel lines, these lines are going to be parallel, and these lines are going to be parallel. Oops, that is not a parallel symbol. Do not write that. You are going to draw your arrows. Parallel and parallel. Doesn't matter which direction as long as you have the arrows. So, stating in my proof, AB, shouldn't have used orange. I will use the blue. AB is parallel to CD, and AD is parallel to CB. And how do I know that? We already said it. Alternate interior angles, yes, but that's for the angles. Because I'm stating the lines, it's alternate interior angles converse. So this is alternate interior angles converse. So, did I just prove this to be a parallelogram? Yes. I proved it to be a parallelogram. A, B, C, D is a parallelogram because I just stated by showing you that opposite sides are parallel. I just stated the definition of a parallelogram. And just if you don't know what the definition of a parallelogram is, I'm going to write it. If both pairs, keep in mind it has to be both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. Go ahead and submit your notes, please. It says everything for your quiz on Tuesday. Please study.